This is AP Calculus 1.4, estimating limit values using tables. And sometimes they're going to give you a limit problem like in these examples. And this one says to find the limit of 1 over x as x approaches 0. And the directions are going to tell you to find that limit using a table. Now, sometimes it's not going to be practical to use anything but a table to do these. Some of these would be fine to graph or maybe do some algebra with, but I'm going to use these to show you how to use tables to do limits. So tables might not be the best way to do these problems, and that's okay, but I'm just using them to show you how tables would work. So that if the directions tell you to use a table, you know how to go about doing that. Okay, so using the limit as x approaches 0, if you think about this, if we were to just try to plug 0 in, we would get something that's undefined. So we need to understand what's happening to the right and to the left of 0 if we're trying to find the limit of this function. So what I would do is I would pick some positive numbers and some negative numbers that are leading up to 0. Because if you think about that, if we had a graph and 0 is the x value we're approaching, what we need to do, we know that there is an asymptote at the y-axis. So we need to know, well, is this thing going up in both directions? Is it going down in both directions? Is it going in opposite directions? We don't know what it's doing. So the only way to figure that out is to pick some positive numbers and some negative numbers on both sides of 0. So 0 is what we're going to approach from both sides. So if I take the negative numbers to the left of 0. Now, we're not going to pick numbers like -5, -3, -2. Those are too far apart from 0. We need to know what's happening right as you get to 0. So I'm going to pick something like -0.0001 and -0.001. -0.01 and -0.1. Those are all some good numbers that are very close to 0. That is, they're going to tell me pretty easily what's happening as we approach 0. And then maybe from the positive side, I might pick 0.0001, 0.001, 0.01, and 0.1 to see what's happening with our graph. So if I do that, I'm not going to do these by hand. That's too much trouble. I'm going to use a graphing calculator or Desmos to generate the y values of this point. I think that a graphing calculator is easier because you can just put the equation in and get your y values very quickly. So that's what I'm going to do. I would encourage you to go ahead and do that, find the y values for that, and then we'll do a few different examples using our calculator to see what happens. Okay, so I've gone ahead and I filled in the table for the x values that we've chosen, and I just did that with a graphing calculator. It's pretty simple. And what I can see here is that as x approaches 0 from the left-hand side, it looks like this number is increasing very quickly. It looks to me like it's approaching negative infinity moving in from the left, and look at what's happening here as we move from the right and get closer and closer to 0. These numbers are getting very big very quickly, so it looks like it's approaching infinity moving in from the right. So these two things are approaching two very different numbers. The top, as x approaches 0 from the left, or the one-sided negative limit, is negative infinity, and the one-sided positive limit is positive infinity. So for this one, I would say the limit does not exist because it's approaching different things from both sides. In the second one, they're wanting us to approach 1, and so I'm doing that on the table. I've got 1.1, 1.01, 1.001, and as you can see, the y values, and again, I put these in the calculator, the y values here are approaching 2. So 2.1, 2.01, 2.001, and I would venture to guess that if we keep going, it's going to get closer and closer and closer to 2 until eventually it reaches 2. And then from the left, it's approaching 2 as well. These numbers are getting closer and closer and closer to 2. So since it's doing the same thing on both sides, the limit there would be 2. In the third example, if we approach 3 from the left, it looks like our numbers are approaching 5. And if we approach 3 from the right, again, it looks like our numbers are approaching 5. So the limit here would be 5. And then last, the limit as x approaches 2, we're going to, from the left, plug in 1.9 until we're approaching 2. From the right, we get closer and closer to 2 from the right-hand side. And look at what's happening to our numbers. It looks like this is approaching 0.6 repeating. It looks like this one here is approaching 0.6 repeating. So I would say that that one is either 0.6 repeating or 2/3. Okay? So they don't always have to approach a whole number. Sometimes they might approach a fraction. And depending on what you've been given, you may not be able to get an estimate for what your decimal is. You may have to leave it as a decimal. You just have to make sure you estimate based on what they've asked for.